Hello there. Now that you are good at measurements and significant digits, we're going to look at a method today to help us with converting between various units. This is going to be very helpful in chemistry because there's all sorts of units in chemistry that are kind of unique. So we're going to start with units that we're all familiar with from our ordinary lives, things like masses and volumes and fluid ounces. And we're going to be converting them into units like moles that are not used in everyday life, but are very important in chemistry. And so for that purpose, we're going to need a way to convert. Now, there's converters you can get on your phone that do a lot of these things for you. But the factor label method is a good way to do it manually because it is applicable for all sorts of things. And what if your phone runs out of batteries? All right, so let's go. So first of all, whenever you're going to convert from one unit into another, you're going to need some conversion factors. You're going to need to know the relationship between one unit and another unit. And there's a bunch that you probably already know. Most people know that 1 meter is 100 centimeters. Most people know that a 1 minute is 60 seconds. So those are all conversion factors, right? A kilogram, kilo anything, is 1,000 grams or 1,000 anythings. So these are ones that I would hope that you are already familiar with, but there's some weirder ones like that you probably don't know, like 2 tablespoons is equal to a fluid ounce, which is not something I knew until I looked it up for this slideshow. So in order to convert between different units, we're going to use the factor label method, and it uses sort of a set of steps that are always sort of the same way, and it can be likened to a little train. You're going to see that there's different values that can be added like cars on a train, and there's always something that you put at the beginning, which is kind of like the engine, which is like your target, the value that you're looking for. So first of all, you're going to write the name or the unit of that thing that you're looking for. We'll call that the target. And then you're going to look for in the problem or from the data that you have a given value, a measurement that you can start with. And then you're going to use those conversion factors to convert from one unit into another until the unit you get is the target unit. So when the right side of the equation equals the target unit, you can stop. So what does that look like? We're going to look at an example in the next slide. Okay, so let's use a quantity that we're all fairly familiar with, minutes and hours. And so from this question, it says how many hours in 825 minutes? And so what is our target? What is the thing we're looking for? And so if you look through the question, you see how many hours. So we're looking for hours. So I'm going to write down hours. So hours is our target unit. Let me put a little equal sign. And then what is a given value that we have? Given value is the 825 minutes, right? So now we got our given value. And then we can use a conversion factor. So we need a conversion factor that goes from minutes. You're always going to put the one that you just wrote, put that on the bottom of your conversion factor. And we want to go into hours, the thing that we're looking for on the top. So most people know that there are 60 minutes in 1 hour. And so I should be able to work out the answer to this if I take the 825, multiply by 1, and divide by 60. And of course, multiplying and dividing by 1 is unnecessary because it's the same number, so we can just skip that part. So 825 divided by 60 gives me 13.75. 13.75. So that'd be 13.75 hours. And of course, if we're looking at our significant digits here, the only measurement is the 825 minutes, which is 3 significant digits, which means I have to round that. And that's a 5 on the end, so it means we got to go to the nearest even value, which is 13.8 hours. Yay. All right, so once you have this method down, you can add conversion factors as needed. There won't always be a single conversion factor to go from the thing that you have to the thing that you're looking for. And so let's have a look at one where we have to use several steps. So in this one, it says how many seconds are in this many days. So our target is going to be the seconds. So I'll write that down. And our given value is 0.83 days. All right, so conversion factors. Do you know how many seconds are in a day? I do not. But what do I know about days? I know that there is 24 hours in a day. So that helps me get closer to my target unit. So the days will cancel out. And then I can add another conversion factor, just like another train on the car here. And what do I know about hours? Well, I know that there's 60 minutes in an hour. That gets me a little closer, right? 60 minutes in 1 hour, that cancels out the hours. Now I've got minutes. Ooh, getting closer, almost to the right unit. And then what do I know about minutes? Well, I know that 1 minute is 60 seconds. And 60 seconds, ding, 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 is my target unit. So as soon as the target unit is found on the right-hand side, you'll know that you're done. Then it's just a matter of doing the calculation. There's a bunch of ones on the bottom there. We can just ignore those. And everything on the top, we're going to multiply. So 0.83 times 24 times 60 times 60 equals 7.1. Oh, wait a second. No, 71712. All right. Equals 71712 seconds. However, there are only 2 significant digits in this value, and so it's going to be 72,000 seconds for the right accuracy. Great. Hope that made sense. Okay, so let's see if we can use our factor label method to do a few of these conversions. First of all, we're looking for millimeters, and we are given 5.2 inches. And from my chart here, I know that an inch is this many centimeters. So 1 inch equals 2.54 centimeters. And that's almost millimeters because I know in 1 centimeter there are 10 millimeters. Now the right side equals the left side. I am done. Inches cancel out, centimeters cancel out, or divide it, however you want to say it. All right, so let's try this one. 5.2 times 2.54 times 10 equals, and I've got 132.08, 132.08, and if I put that into the right number of significant digits, it's just 2, so 130 millimeters. Great. Number 2, miles we're looking for this time. And we have 8,945 feet. What do we have here? We know there are, we can go from feet to yards, and then we can go from yards to miles. Nice. Okay, so there are 3 feet in 1 yard, and there are 1,760 yards in 1 mile. Great. So feet cancel out, yards cancel out. What do we have here? 8,945 divided by 3 divided by 1,760 equals, whoa, my goodness, big number, 1.694 blah blah blah, 1.69412 miles. And we're just going to keep 4 of those digits, so it's 1.694 miles. Great. So these are all like imperial conversions. We're never going to use these. But the point is not the units. The point is being able to use factor label method and see how to set it up so that the units all cancel each other out. That is the object of this little exercise. All right, we're going to do inches this time. So we have 86.2 miles. This is going to be a lot of inches. All right, what do you know about miles? We can go from yards to feet to inches. Look at that. So there are, again, 1,760 yards in 1 mile, and there are 3 feet in 1 yard, and there are 12 inches in 1 foot. And that comes out to 80, oh my goodness, the phone's ringing. Okay, that gives me 5, 4, 6, 1, 6, 3, 2 inches. That's a lot of inches. I only have 3 significant digits there, so I'm going to keep the 5, the 4, and the 6 and put zeros in for all the rest of it. So that is 5,460,000 inches. And that many miles. Wow, that's a lot of inches. Okay, let's try a couple more here. This time using gallons and teaspoons. Admittedly, we won't do a whole lot of that in chemistry class, but we are going to use the same principle of the factor label method. So here we are, we're looking for gallons this time, and we are given 3.35 meters cubed, and we can see that a meter cubed is 1,000 liters. So 1 meter cubed, see we put the unit on the bottom, 1,000 liters. Those cancel out. Now we got liters. And then we can go to gallons because we know there's this many liters in a gallon. So we got 3.785 liters in 1 gallon, and liters cancel out. And let's work this out. 3.35 times 1,000 divided by 3.785 equals, and I've got, wow, 885. I guess we're keeping 3 sig figs. 885 gallons. Great. Last one. How many pints? We're looking for pints. And we have 873 teaspoons. Well, let's see what we can do here. We got teaspoons here. We're going to go to tablespoons, tablespoons to fluid ounces to gills, gills to pints. Look at that. Okay, so there are 3 teaspoons in 1 tablespoon, and there are 2 tablespoons in 1 fluid ounce, and there is 5 fluid ounces in 1 gill, and there's 4 gills in a pint. Now there's a great Irish Rover song that has all these measurements in it. It's pretty funny. You give it a look. So tablespoons or teaspoons cancel out, so do tablespoons, fluid ounces, and gills. We end up with pints. So let's do this. 873 divided by 3 divided by 2 divided by 5 divided by 4 equals, look at that, 7 point, how many sig figs we got? 3. So 7.275. And since it's a 5 on the end, we're going to round that to 7.28, round to even. Very nice. Pints. Great. Okay, let's finish this. Now, one unit we do use fairly often in chemistry is that of density, and we use a lot of water as well. So just a reminder from grade 9 that the density of water is 1 gram per milliliter. So if you find out grams, then milliliters will be the same thing. It's pretty easy. You can demonstrate that using factor label method if we're looking for the volume of 220.0 grams of water. Well, water is 1 gram for every 1 milliliter, so that means you've got 20.0 milliliters of water. So that's a handy conversion that you'll see from time to time. And if it's not in milliliters, then you can always convert using our handy chart here. So we're going to go from quarts to gallons, gallons to liters, then we go to milliliters, and then we get mass, right? So we'll do mass equals 2.5 quarts, and there are 4 quarts in 1 gallon, and there are 3.785 liters in 1 gallon, and there are 1,000 milliliters in 1 liter. And since it's water here, it's 1 gram for every 1 milliliter. So, little calculator action here. 2.5 divided by 4 times 3.785 times 1,000 equals, and we end up with, what do we got there? Wow, it's a big number. 2,000 blah blah blah. So we got 2 sig figs, so that's just 2,400 grams. There we go. Okay, just to wrap things up here, the reason why I encourage the use of factor label method is that it gets us around having to try to memorize a whole bunch of formulas. I'll show you some of the formulas and relationships, but I generally won't use them because I like to focus on the units, and using factor label method helps to do that. So you can do some of the conversions that we're going to see later on that are useful in chemistry using formulas, but I find that helps you be more organized, helps you focus on the units, because oftentimes If there's a formula, people just plug in numbers and forget about the units, and that can lead to some confusion later on. And also, you can use this for all sorts of other things, math, physics. There's other courses out there where factor label method is really useful. Okay, take care.